Now let's take a look at how we can price caps and floors under vessel check. Essentially, we still just gonna price a caplet and a floorlet. Once we're able to price a caplet and floorlet, a cap is just a collection of the caplet, and the floor is just a collection of floorlet. So then we're able to price caps and floors. So to look at a caplet, first of all, we see that a caplet provides a payoff like this that we have seen before, okay, for a particular period. If we fix the rate at TI and we get a payment at TI plus 1, okay? So this is the notional. This is really the time difference, so maybe like a 3-month. If I plus TI, between TI plus 1 and TI is 3 months, this delta I will be 0.25, okay? And which is used to calculate the actual rate because all the rates here is annualized. So with a notional and a time period here, with this payoff function at TI plus 1, we see that actually this payoff is deterministic at TI, because once you at TI, you know the rate, you know exactly what's going to be paid, and you know the interest rate. So you can actually discount it. So of this TI plus 1 value at TI, so you get a present value as of TI of this payoff, which is this thing here. And you can rearrange them to have something more meaningful. So you arrange them, you get a condition here by putting this inside the max function here. Now to see how that is done, I've basically written it out here. So, this part is just this times Ri is this times Rk is this part here. So you just follow this derivation, you will have this, which is this condition here. So what then is this thing, right? Which is this. Well, so this thing is really the time value, the value at time Ti of a 0 coupon bond that pays off this part at Ti plus 1, right? So this is the discounting, right? So essentially, when you have this max function of L minus this thing, so L is minusing a present value. So this max function is really then the payoff from a put option, right? So you can look at this L as a strike price. With the put option has a maturity of TI and is on a 0 coupon bond that has a maturity of TI plus 1. Okay, so we need the 0 coupon bond has longer maturity than the option, which is okay. And the face value of the bond is this thing here. So this thing is the discounted value, and this is the maturity value of the 0 coupon bond. L times the bracket 1 plus RK delta I is the maturity value of the 0 coupon bond. 0 coupon bond, and this L, which is the notional, what can be treated as the strike price. So basically, we now have changed the problem of pricing the interest rate caplet to the problem of pricing a put on a 0 coupon bond. So this is basically, if this is the strike price of the put, and this is the current value of the maturity value of the 0 coupon bond, we now have a put on a 0 coupon bond. And we know the call and put call price formula and the put price formula for vessel check model. So we can utilize that. In this case, will be for caplet, we'll use the put formula. So this is the put formula for the vessel check process. And so we can utilize that. We'll have to replace A in the formula with the cap notional, and B, which is the, then we have to replace that with this maturity value of the zero coupon bond. Okay, so then we use this put formula, we can price any caplet. Now we should treat as an exercise how we can price the a floorlet under the vessel check model. So in this case, for floorlet, you will use a call price formula under vessel check.